To all my viewers, feel most welcome to this channel. As in our session for today, we are going to discuss about finding the Laplace transform of our function f of t is equals to sine t everything squared. When it comes to finding the Laplace transform of a function like this one, there are multiple things that we need to carry out before even starting out our working, finding the Laplace transform of the function that we have here today. To mean that in the most important thing that we need to understand when we are starting is about the first principle formula, because that is what we are going to use in finding out the Laplace transform of our function of today. When it comes to the first principle formula, we know that the Laplace transform of our function f of t, which is equals to sine t squared, is going to be equals to, here we are going to have an integration with respect to our limits, the upper class limit and the lower class limit, exponential negative st we multiply by our function f of t, and our integration is with respect to dt. In our next step, we are going to replace our function f of t with respect to sine t squared, to mean that we are going to have the Laplace transform of sine squared t is going to be equals to an integration with respect to our limits, exponential negative st we multiply by sine squared t, and our integration is with respect to dt. From this point now, we are going to rewrite sine squared t into its simplest form. Using the trigonometric functions formula, we understand that sine x everything squared is equals to a half into 1 we subtract from cos 2x, to mean that our function sine squared t is going to be equals to a half into 1 we subtract from cos 2t. At this point now, we can come and continue with our working, whereby we understand that the Laplace transform of our function f of t is going to be equals to an integration with respect to our limits, exponential negative st we multiply by sine t squared is equals to whatever we are having here, a half into 1 we subtract from cos 2t, and our integration is with respect to dt. Let us now simplify whatever we are having at this point, and by simplification of whatever we are having at this point, we are going to factor out a half because it is not a term of dt, and we are going to open the bracket. By doing that, we are going to have, by simplifying whatever we are having within the brackets, we are going to have the Laplace transform of our function f of t is going to be equals to a half, an integral with respect to our limits. Let us now open the bracket. We take our decay function, which is exponential negative st. We multiply by 1 is going to be that. We subtract from exponential negative st cos 2t, and our integration is with respect to dt. At this point, we've only factored out a half and opened the bracket. Let us now move into our second step. Before we do our integration, the first and most important thing, we need to convert cos 2t into an exponential. And by converting cos 2t into an exponential, we need to know that exponential theta j is equals to cos theta we add to j sine theta. This is the complex number formula, whereby our angle theta is going now to be equals to 2t, and here we are going to have exponential 2t is going to be 2tj, because this is the angle theta, 2t j cos 2t we add to j sine 2t. At this point, we can come and say r exponential 2tj is equals to r cos 2t. R stands for the real side. On the imaginary side, we can come and say or exponential 2tj is equals to j sine 2t. This one stands for the imaginary side, and our first function here stands for the real side. Let us now proceed with our working, because we've converted now cos 2t into an exponential. We can come and say now that the Laplace transform of now our function f of t is equals to a half into an integral with respect to our limits exponential negative st. Here we subtract from exponential negative st cos 2t is going to be equals to, here we agreed, r exponential 2tj is equals to cos 2t. We are going to replace with that, and our integration is with respect to dt. From this point now, on this side, we need to simplify it further, and by simplification of this side, we are going to have the Laplace transform of our function f of t is going to be equals to a half our integration with respect to our limits exponential negative st. We come and subtract from here. We are going to have our integration sign, because it was an integration of this one and this one. So here we can come and introduce our integration sign. We factor out r, because it is not a term of dt, and here we are going to use the loss of indices in simplifying whatever we are having here. And by the laws of indices, we understand that when the bases are equal and it is a multiplication, we take one of the bases and we add the powers, to mean that we are going to have exponential negative s we add to 2. Here we are having our function of t, and our integration is with respect to dt. From this point now, we can just do our integration, whereby we understand the Laplace transform of our function f of t is going to be a half into, here we are going to have exponential negative st all over negative s. Here we are going to have our class limits. We subtract from r into, here we are going to have exponential negative s we add to 2t all over negative s we add to 2. We come and insert our limits. Let us now do away with the class limits in each and every function. Sorry, I'm forgetting about something. Here we're supposed to be having a j, here a j, here a j. Yes, that one supposed to be there from this point. Yeah, from this point, sorry. We can come and now say, from this point now, we are going to do away with our class limits. And by doing away with our class limits, we are going to have the Laplace transform of our function f of t is going to be equals to 1/2 into, here we are going to have 1 all over negative of s, we multiply by exponential negative s, we insert our upper class limit, we subtract from exponential and negative of s, we multiply by our lower class limit. We come and subtract from, on this other side we are going to have r all over a negative of s, we add to 2j. We come and multiply by exponential negative of s, we add to 2j. We insert our upper class limit, we subtract from exponential negative of s, we add to 2j. We come and multiply by our lower class limit. In our next step, we are going to have the Laplace transform of our function f of t is going to be equals to 1/2 into, here we are going to have 1 all over a negative s into 0, we subtract from 1 because we understand when an exponential is raised to a power of infinity, it is equals to 0, and an exponential raised to a power of 0 is equals to 1. We come and subtract from r all over a negative of s, we add to 2j. Everything we multiply by, here we are going to have 0, we subtract from that. At this point now, the negatives here are going to affect whatever we are having on the denominator. To mean we are going to have the Laplace transform of our function f of t is going to be equals to 1/2 into, here we are going to have 1 all over s, we subtract from r all over s, we add to, here we are going to have a negative of 2j. To this side, we've simplified it into its simplest form. When it comes to this side, we need now to separate the real functions and the imaginary function. By separation of the real functions and the imaginary function, we must do rationalization. When it comes to the rationalization, we understand that r into, here we are going to have 1 all over s, we subtract from j, we come and multiply by the conjugate of the denominator. To mean we are going to have s, we add to 2j, s we add to 2j. Here now we are going to have, on the numerator we are going to have r into s, we add to 2j all over. Here s multiplied by s, we are going to have s squared. We add to 2sj. Here we are going to subtract to 2sj all over. Here we are going to have a negative of 2j, but everything is going to be squared. Here I'm working out on simplification of whatever we are having here, whereby we say that we need to do rationalization for us to have the real function and the imaginary function. At this point here on the denominator, these two are going to cancel out one another, and we are going to have r into s. We add to 2j all over s squared. We subtract from, because these two are going to cancel out, for j squared. At this point, we agreed that j squared is equals to a negative of 1. To mean that when we replace j squared at this point with a negative of 1, this a negative of 1 is going to affect the sign that we are having here. Hence, we are going to have a negative. When we multiply by a negative, we are going to have a positive. Let us now separate the real functions and the imaginary function. By separation of the real function and the imaginary function, at this point we are going to have r into s. We add, all over s squared, we add to 4. We come and add to 2j all over s squared, we add to 4. Here now we've separated the real functions and the imaginary function. But since we were working with the real functions, hence we can come and say our answer here now is equals to s all over s squared, we add to 4. Because of the r here, we are going to take the real side and ignore the imaginary side. Let us now get back into our working, whereby we say that the Laplace transform of our function f of t now is going to be equals to a half. We multiply by 1 all over s. We subtract from s all over s squared, we add to 4. Here now we can do our cross multiplication to simplify this fraction. And by cross multiplication, this is what I mean. We are going to take this, we multiply by 1. The Laplace transform of our function f of t is going to be equals to a half into, here we are going to have s squared, we add to 4. When we take whatever we are having here, we multiply by that. We subtract from s squared, and everything is going to be all over this one multiplied by this. We are going to have s cubed, we add to 4s. These two are going to cancel out because this one is a positive of s squared, this one is a negative of s squared. We are going to have the Laplace transform of our function f of t is equals to a half into 4 all over. On the denominator, we are going to have s cubed, we add to 4s. These two will cancel out with that, and we are going to have the Laplace transform of our function f of t is equals to 2 all over s cubed, we add to 4s. And this is how you go about finding the Laplace transform of our function st everything squared, to mean that the Laplace transform of our function sine is equals to s cubed we add to 4s using the first principle. Laplace transform generally, as I conclude here, it needs a lot of practice and understanding some fundamental concepts such as rationalization, how to insert your limits, how to do away with the limits, when to carry out your integration, when to change. For example, you can be given sine, how you change it into an exponential cos. Those are the basic things that you need to understand. Otherwise, let us meet in my next session, whereby I will still be discussing the most important concept and example on working out the Laplace and transform. Thank you so much for your time.